Today, we're taking a trip to the heart of a giant elliptical galaxy called M87, where a true monster resides. No, not a giant alien or a giant robot, but something even more terrifying, a supermassive black hole. Imagine, if you will, a giant monster that devours anything that strays too near. Stars, planets, gas, and dust. Nothing escapes its grasp once it crosses a threshold called the event horizon. This giant holds trillions of stars and helps anchor the roughly 2,000 galaxies, including the Milky Way, that makes up our local cosmic city, the Virgo cluster. But the Virgo cluster is just a small piece of the puzzle, as it's a primary component of the much larger Virgo supercluster. Now, scientists have finally given us a glimpse of this monster by unveiling an image of it. The black hole has the same mass as 6.5 billion suns. Can you even imagine that? It's like trying to imagine how many times you blinked in your lifetime. It's impossible. But you might be wondering, how did this monster form? Well, to start with, what is a black hole? A black hole is a cosmic body of extremely intense gravity from which nothing, not even light, can escape. It's like a giant vacuum cleaner that sucks in everything in its path. A black hole can be formed by the death of a massive star. When such a star has exhausted the internal thermonuclear fuels in its core at the end of its life, the core becomes unstable and gravitationally collapses inward upon itself, and the star's outer layers are blown away. Black holes usually cannot be observed directly on account of both their small size and the fact that they emit no light. But don't worry, we're not leaving you in the dark. Scientists observe black holes by the effects of their enormous gravitational fields on nearby matter. For example, if a black hole is a member of a binary star system, matter flowing into it from its companion becomes intensely heated, and then radiates X-rays copiously before entering the event horizon of the black hole and disappearing forever. Did you know that the Milky Way could contain over 100 million black holes? Yeah, that's a lot of holes in space. But don't worry, we're here to help you understand these mysterious objects. Are you enjoying this video so far? If so, show us some love by hitting that like button and subscribing. Your support helps us continue creating high-quality content for you to enjoy. First off, let's talk about the big kahuna of black holes, the supermassive black hole at the center of the Milky Way, Sagittarius A. This bad boy is about 4 million times the mass of the Sun and is located about 26,000 light-years away from Earth. That's like the equivalent of traveling to the Moon and back 26,000 times. Mind blown yet? But before you start freaking out about black holes sucking us all into oblivion, let me clear something up. A black hole is not actually a hole. It's an object just like any other, except it's extremely dense and has a super strong gravitational field. So strong, in fact, that nothing can escape it, not even light. But don't worry, we're safe here on Earth. So, what would happen if you fell into a black hole? First off, let's talk about the old theory that suggests that if you fell into a black hole, gravity would stretch you out like spaghetti. But hold on, because a recent study from 2012 published in the journal Nature suggests that quantum effects would cause the event horizon, which is basically the surface of the black hole, to act like a wall of fire and burn you to death before you even reach the center. Now, let's talk about the center of a black hole, the singularity. It's hidden by the event horizon, and inside that, the escape velocity is faster than the speed of light. So in other words, nothing can escape. But don't worry, the size of the event horizon, also known as the Schwarzschild radius, is proportional to the mass of the collapsing star. So the bigger the star, the bigger the black hole. Now, let's talk about types. There are a few different types of black holes, and we'll start with the little guys. Stellar black holes, formed by the collapse of individual stars, may be small in size, but they pack a heavy punch, with more than 3 times the mass of the Sun crammed into a city-sized diameter. These black holes have a gravitational force that would make even the strongest sun quiver. These black holes mostly just chow down on dust and gas from their surrounding galaxies, getting bigger and bigger. Next up, we have intermediate black holes. You can think of them as the middle children of the black hole family. These were a surprise to scientists who originally thought black holes only came in small and large sizes. But research has shown that these mid-sized black holes, or M87s, could form when stars in a cluster collide in a chain reaction. And if you thought M87s were impressive, wait till you hear about supermassive black holes. These giants have a combined mass of more than 1 million suns and can be found at the center of every large galaxy. The supermassive black hole at the center of the Milky Way, Sagittarius A, has a mass equal to about 4 million suns and could fit inside a ball that could hold a few million Earths. But the real star of the show is the black hole in the nearby galaxy Messier 87, or M87 for short. We've got an actual picture of a black hole, and it's like looking at the Mona Lisa of space. But before we dive into the details, let's set the scene. Imagine a group of scientists huddled around a computer screen, staring in awe at the image that's about to change the way we think about the universe. Suddenly, one of them turns to the others and says, "I can't believe we're actually seeing this. It's like looking into the abyss of space." And that's exactly what it is. The black hole at the heart of M87 was taken over a window of 10 days in April 2017, using the power of 8 large radio telescopes around the world. Now, you might be wondering, why did it take so long to get an image of a black hole? Well, for starters, the black hole itself is 6.5 billion times more massive than our Sun, and it's incredibly small at this distance. It's like trying to take a picture of a tennis ball on the moon with your phone camera. But with the help of the EHT project, scientists were able to combine the power of these telescopes to create an Earth-sized virtual super telescope. And the result? A ring of fire surrounding the blackest of shadows. It's a powerful confirmation of Albert Einstein's theory of gravity. Now, I know some of you may be thinking, wait, black holes don't emit light, so how can we see them? Well, that's where things get interesting. Think about it like this: when you take a selfie, you use a flash to illuminate yourself, right? But if you were to take a selfie in total darkness, it wouldn't be much of a selfie. The same goes for black holes. If we could magically transport ourselves to the vicinity of an isolated black hole and had a camera with a flash, the picture would be pretty different. The flash from the camera would emit light in all directions, but the light going along the central line of sight to the hole would be absorbed and not returned to the camera. This also applies to rays that make a small angle with the line of sight to the center. So what does this mean? It means that we would expect a central dark region in the picture, the shadow of the black hole. Rays emitted from the black hole can be divided into 3 categories. The first are rays that are emitted at large angles to the line of sight, which disappear into space and never even come close to the black hole. The second are rays that are emitted at angles closer to the line of sight, which get bent by the gravitational field of the black hole. And the third are the rays that are the most interesting. They bend all the way around the black hole and return to the camera. This means that we can expect to see a ring of light around the black hole. As the rays get closer and closer, we see a series of concentric rings, just like in the image that was captured. But here's the kicker. It took 4 petabytes of data, or 4 million gigabytes, to capture this image. That's so much data that it had to be physically transported by sea and air before it could be processed. And it took the scientists until summer 2018 to finally put the final image together. But this is just the beginning. The scientists are hopeful that this discovery will usher in a new era of black hole observations. The major limitation of this method is the size of Earth. We can't build a virtual telescope on our planet that's larger than the planet itself. But who knows what the future holds?